Hey everybody, I'm Kathy Resnichek.
I'm Richard Pressler with All Connected.
And we're here to introduce you to Module 2 of the Wired Networking course offered by TAP. So in Module 2, we're going to look at the LAN and WAN protocol. So can you tell us what we're going to be experiencing in this module?
Absolutely. So essentially, there are standards that have been agreed upon in order for computers to communicate with one another. And understanding those standards is very helpful because ultimately you may be called upon to troubleshoot a problem between computers that aren't talking to each other, for example, and you need to understand why, right?
So when you talk about standards, is standards and protocols, are those the same?
They're kind of
thing,
interchangeable.
Okay.
Think of it like a diplomatic protocol, right?
Okay.
So when countries meet together, there's protocols about who can talk to who. There's protocols about maybe even the language that they use. They may need to agree on the translators and things like that. So humans often do this. We often have some sort of standard or protocol for how we interact with each other, but we also understand context. So as a human, I can understand context clues in order to understand what somebody's talking about or how to deal with them, right? Well, computers don't really have context. They have no concept.
Not yet.
So when we say protocols in a computer, not yet, yes, artificial intelligence may change that.
That's right.
But when we say a protocol in a computer context, we're really talking about a very strict standard, usually dictated by a document called an RFC, or request for comment. And that document will indicate exactly what problem a researcher or a programmer was attempting to solve and a solution to it. And if everyone adopts that, then they've adopted the same solution to the same problem. So now computers can talk to each other. But they talk to each other at many different layers of the OSI model. So when we talked about the OSI model, we talked about transmitting bits through cables at layer 1. Well, then it gets more complicated when you get to layer 2 because you have to agree on who are you talking to, what's their address, right? Well, that address has to have a standard. How long is it? How are they unique? How are they kept unique? So at layer 2, there's addressing. Also at layer 3, there's addressing. There's logical addressing in order to communicate with each other. So the assignments are broken up somewhat like that. The assignments are basically broken up into first the Ethernet standard, because that's definitely the most common layer 2 standard on the entire planet. Even your cell phone uses Ethernet. And then we'll talk about layer 2 non-Ethernet standards. Those are less common these days. In a K-12 district, you may hardly run into them at all. But it's important to understand that they're out there. And then we'll talk about layer 3 addressing protocols, specifically IP. That's the one that kind of won the internet.
The big one.
When the internet protocol became the de facto standard, then all of the corporate networks and K-12 networks essentially have adopted that. And so very few layer 3 protocols are really common outside of IP. That's it. But there's two types of IP. There's IP version 4 and IP version 6. And so we're going to dive into why that is and what problems are solved in IP version 6. And today in America, I would say IP version 4 is just where we're at within the K-12 community, but we're working towards IPv6
and that's
rather
more
actively.
Business or other countries?
It's just the internet. Well, other countries were forced to adopt IPv6 earlier, for example in Asia, because there wasn't enough IP version 4 address space on the internet to allocate to the country in order for them to use it. IPv6, on the other hand, has exponentially greater number of addresses that are available.
So we used up all the area codes first, and then had to get new ones.
Yeah, and area codes are only in a country. The internet is everywhere. So it's an even bigger problem. But it's also become a problem within some private enterprises and within school districts. So we'll talk about that. And then there's also other protocols that are necessary to exchange routing information between routers about where a network lives. And so we're going to talk about a few of those, specifically RIP, OSPF, and BGP. And those are protocols that are used to determine where a network exists and therefore, and when I say network in this case, I mean like an IP segment, where it exists and therefore where to send the traffic to, what router to send the traffic to.
And you're going to explain all those acronyms in the assignments.
Oh yes, definitely.
So one last thing is the title of this is WAN and LAN protocols. So just for in case anybody doesn't know what a WAN, what does that stand for, and what does LAN stand for?
Sure. So WAN is a wide area network,
Okay.
and LAN is a local area network. You might also hear another term like MAN, metro area network.
Oh, is that like a city?
Yeah, usually within a
Okay.
city. The interesting thing is that the protocols are often very similar. So it used to be that a WAN would use different layer 2 protocols than a LAN.
Oh, okay.
But now I'm finding new circuits from service providers are often Ethernet based. So therefore they're using the exact same layer 2 protocol that I use on the LAN.
Oh.
So the differentiation is becoming more difficult to really draw a line and say this is a LAN, this is a WAN. But for a school district, the way I would view it is the LAN is generally the pieces of the network you own, and the
Okay.
WAN is the things you have to connect to, like for a service provider.
Okay, that makes sense.
If you think of it that way,
Yeah.
that will provide a logical segmentation. It's not the only way to think of it, because some people would also say a LAN is the layer 2 segment and the WAN is when you're crossing layer 3 boundaries. But for the context of this assignment or this module, I would say look at it as the LAN is things that you have in your district, you own them, switches, everything. And then the WAN is things you're connecting to outside your district,
Okay.
like the internet, or maybe you had to lease a line from a provider to get 2 buildings to talk to each other. That would be like a WAN.
Great, that makes sense.
Does that make sense?
All right.
Okay, great.
Looking forward to it.
Let's get started.